Okay, so working on this problem, how many valence electrons does the N have? Five. And each H has how many? So that's a grand total of 3. So we have 8 valence electrons to mess with, to use. So in step 2, what element's going to go in the middle? Nitrogen for sure, right? And we could envision having the H's around it. There's 3 H's. How many electrons does each H want to have? 2. It already has 1, but it only wants 2. So maybe we could imagine a setup like that. Putting the bond between the N and the H. At this one point, I'll let you get caught up, but how many valence electrons have we used? 6. Each hydrogen is content with its 2. How many electrons does the nitrogen have, though? Has 6 around it. 2, 4, and 6. How many does it want? Or do we have any left to use? How many more left do we have? 2. So it would be conceivable to do that. Now how many electrons does the nitrogen have? 8. And the H's each have 2. Right? Okay. So right now you have gone over part 1, which was to draw or write the structure of a covalent compound. Remember that in an ionic compound, like you saw the other day, we use the arrows. Do you remember this? So you have to be telling right away, like in homework 1 that we did, if you have an ionic or covalent compound so that you know what's up. Now I told you that for part 2 today I was going to go over if something was polar or nonpolar. So let's take some notes on that off to the side and we'll see that this is not difficult at all. Polar compound as opposed to a nonpolar compound. A compound that is listed as being polar is going to be one in which the electrons are shared unequally. So this is a covalent compound in which the electrons are shared unequally. In other words, there is a side with excessive electrons. I'm going to give you some examples. I'll let you write these down. Arrow in a specific direction. Yeah, there's a side that's heavy in electrons. The side right there. On the water molecule, is there a side that's heavy in electrons at all? Going almost kind of straight up, right? Do you see how we draw the arrow in a direction where there are tons of electrons? Yes? That's something that's polar. Something that's nonpolar, we could not do this. So a nonpolar compound would be one, a covalent compound, in which the electrons are shared equally. In other words, there is no side with excessive electrons. No side with excessive numbers of electrons. Let me give you some examples. Let you copy these down as well. Some examples you can copy down. These are all, again, covalent compounds. So we can draw those structures with the single lines representing a bond. Two lines, of course, would be a double bond if you think about it. Now remember that if you had a polar compound like you did before, you could draw an arrow to a single side, correct? Can I draw an arrow to a side of heavy electrons in CO2? I could draw one over here, right? But can I also draw one in the opposite direction? It's kind of like they cancel out. When they have that effect of both sides, they cancel out. You have something that's nonpolar. How about in the case of CH4? Do you see any electrons here? Lone electrons, little dots. No. So again, nonpolar, because there's no heavy side of electrons. Now in the case of CF4, can I draw a side to lots of electrons? I could draw a side over here, right? But then I could also do one up to the left. Top, bottom. Remember, when you have them going in equal directions, but in opposite ways, if you will, equal amount, but in opposite direction, like here and here and here, they cancel out, right? Yeah. So cancel out, and you have something that's nonpolar. So all three of these above were polar, because they had a side of electrons, and the three that you see. So we're talking about the number of electrons in the valence level of P, and you said there was 5. Okay, so I should write down a 5 there. And how many valence electrons does the Br have? 7. And that would be times 3, so that's a grand total of 21. So we have 26 electrons that we could use today. Because 21 and 5 is 26. Cool. Which element, Jason, has to go in the middle? P or Br? P? Okay. And how many BRs do we have?
3.
So we should put a BR 3 times over around different sides. Okay, that's simple enough. Okay. What I like to do is I would suggest let's count up those electrons real quick. So BR has how many electrons? So I could do a dot there, 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 and there, and leave one open at this position. Right? And do the same thing for each other BR, putting a single dot directed towards the P, because you know you're going to have to form a bond between the P and the BR. How many electrons have we used doing that? 7 times 3, that's 21, right? We still have 5 left to use. It would seem as though the P is going to have an electron there, there, and there to work well with the BR. We've used 3 more. Now instead of just having 21, we've used 24. 2 more left. Let's think about each BR. 1, how many valence electrons does this BR have now? It had 7, but now it's got 8. Breslin, how about this BR? 8, so all the BRs are happy. How many valence electrons does the P have, though? It's got 6, yeah, you can count it. 1, 2, 3, 4, 5, 6. So the P is still messed up. And remember, we've used 24 electrons at this time. So where do you think my 2 last ones are going to go? Yeah, on the P. Very good. So you could draw it like that. That's fair enough. Or you could do the little line to connect the P and the BR. That's fine as well. Now, would you call this polar or nonpolar?